Welcome. This is the 2025 TJ Admissions Exam Math Science Problem Solving Essay Solution hosted by EduAvenues and TJHSST. For today's agenda, we're going to begin with a quick overview of the problem itself. It included 3 different components, so we'll go through each of those components individually, showing you how to solve them step by step, and then we'll wrap up on some key takeaways and our conclusion. So starting us off with the overview of the prompt itself. This was the prompt. This is one of the longest prompts that we've seen for TJ admissions in recent years. It began saying part 1. In 2022, 2 forest organizations realized they were losing too many trees to deforestation. Deforestation is when trees in a forest are cleared to make space for agricultural needs or to get wood as a resource. Currently, a 20 square kilometer forest in Oregon is experiencing deforestation at a rate of 0.2 square kilometers per year. Then they give us a similar forest, but in Scotland, it has an area of 50 square kilometers, and it's experiencing a deforestation rate of 0.8 square kilometers per year. And there has been no reforestation in the deforestation areas. Now, within part 1 alone, they've actually asked us multiple sub-questions labeled as A, B, and C. For A, it is, if the deforestation rates continue, in what year will the forest be the same size? B, what size will the forest be in square kilometers when they're the same size? C, which forest will disappear sooner? And as kind of a subcomponent to part C, by what year will this forest be completely gone? So already we have multiple parts of this problem as well as subcomponents of those parts. Now, here we have part 2 and part 3. Part 2, Scotland stopped cutting down their trees and recognized its need to address deforestation rates through reforestation. Reforestation is the process of replanting trees in areas that have been affected by tree loss. A reforestation project wants to increase the Scotland forest back to its original size, and they give us that original size at 175 square kilometers. Now we have our part 2 subcomponents, A and B. How many square kilometers of trees would the reforestation project have to plant per year in order to restore this forest back to its original size by 2092? And B, what will be the net change of the forest in 20 years? Then in part 3, they discuss the first 20 years of deforestation, and they describe all of this carbon dioxide that's been released into the atmosphere. And they say if 1 square kilometer of forest is planted through reforestation, and that 1 square kilometer absorbs an average of 10 kilograms of carbon dioxide per year for the first 20 years, will the first 20 years of restoring the forest be enough to absorb the amount of carbon dioxide released? And they're asking us to round to the nearest 10th, and they give us a conversion factor here within the prompt itself as 1 metric ton is equal to about 1,000 kilograms. So that's the prompt. And if you haven't already, we would encourage you guys to pause here, try to solve the problem on your own before looking to our solution. We will get into the problem overview in terms of the concept. So now we've just looked at the prompt itself, but really to solve, we need to know some of the following concepts. Remember, there were 3 separate components, each with multiple sub-questions, and different parts of the prompt might involve different concepts, and you might have to combine concepts together in order to solve this TJ math science problem solving essay. That's quite common. So the first concept that we needed to know was a very fundamental Algebra 1 concept in linear equations. So students needed to understand how to create equations using the slope-intercept form of a linear equation, y equals mx plus b. Of course, you could likely use other forms of linear equations as well, but this is the most common slope-intercept form, and in my view, the easiest to think about this particular problem. We also needed to understand basic inequalities, so understanding if our computed values are greater than or less than the given thresholds within the problem. Finally, A concept that would be helpful, even though it's not absolutely 100% necessary, this would dramatically speed up your calculations, is understanding Gauss's formula, or the sum of an arithmetic series. So students really needed the ability to add numbers with a common difference very quickly. Now, you can sit there and add a lot of these numbers up manually. Now, there's nothing that stops you from doing so. But of course, the TJ admissions exam tends to be a time crunch. So it's valuable to have some of this knowledge, even though it may not always be directly taught in your school's Algebra 1 class. So here we go with the solution itself and the remainder of the agenda. Once again, it's divided up into 3 parts. We're now going to get into part 1, which is understanding the linear equations behind these different forests and setting them equal to one another. So part 1, remember, we wanted to find an equation that represents each of the 2 forests. So we began with this equation that represents the Oregon forest. And that was in the form, of course, y equals mx plus b. In this case, m would be our slope, which is negative 0.2. That is the rate at which this deforestation is occurring. And then this right here is actually our b component. This is how much we started with. So if you really think about the entire equation, we're saying that we begin with 20 square kilometers, and every year we're going to lose 0.2 square kilometers. So for example, at the end of the first year, x would equal 1. So our final value would be 20 minus 0.2 times 1, or 20 minus 0.2, which gets us to 19.8. Then at the end of year 2, we can plug that in for x, and so on. So x really represents the number of years that have passed, and y represents the amount of the forest that is still remaining. And we have the same thing for Scotland, except this time we're starting with 50 square kilometers, and we are deforesting at a rate of 0.8 square kilometers per year. Now, the question really was asking us when these 2 components are equal. So when do the forests end up with an equivalent size? And really, the way that we could think about it is setting y equal to y. So we can say that 20 minus 0.2x, so the Oregon forest, is equal to 50 minus 0.8x. And at this point, if we solve for x, that will give us the year at which these 2 forests are equivalent in size. So when we solve for x, we can take that negative 0.8x, add that to both sides to eliminate this one over here. So we end up with 20 plus 0.6x equals 50. We can subtract 20 on each side, and we would end up with 0.6x equals 30. At that point, we can divide by 0.6, or another way to think about that is just multiplying by the reciprocal, which is 5 over 3. So we could say that x is equal to 50 years. Next, find the area at 50 years. To find the area they both have at that time, we want to be substituting that 50 years value into either equation. So in this case, we can just use Oregon's and say y is equal to 20 minus 0.2 times 50, or 20 minus 10, or in other words, at 50 years, they will both have an area of 10 square kilometers. We have now answered the major components of part 1, but we're not finished. There is a little bit more to the problem, and this is where we start to answer part 1C. And they were asking us specifically, well, which forest is going to disappear completely first? Now, the Oregon forest will go from 20 square kilometers down to 0, right? Because once it gets to 0, that means it's completely disappeared at a rate of 0.2 square kilometers per year. That means it would take the Oregon forest 20 square kilometers divided by 0.2 square kilometers per year, or about 100 years to completely disappear. So if it takes 100 years to completely disappear, and we're starting from 2022, remember that was given in the prompt, Well, then we know that the Oregon forest disappears completely, as in gets down to an area of 0 around 21, 22. Now, Scotland begins with a much larger area, about 2.5 times the size, at 50 square kilometers. And we want to see, okay, when's that going to go down to 0? Remember here, even though we start with more, we also have a faster rate of decline. So it'll take 50 square kilometers divided by 0.8 square kilometers per year, or in other words, 62.5 years. So we know that the Scotland forest will disappear around 2084 to 2085, somewhere in between those two. So therefore, Scotland's forest will disappear first, right? 2084 happens before 2122. So it'll disappear by around 2084, or about halfway through that year. So just to recap, once again, we have our Oregon forest, and we're going down from 20 square kilometers to 0 at a rate of 0.2 square kilometers per year. It's disappearing in 21, 22. We have the Scotland forest starting at 50 square kilometers, going down to 0 at a rate of 0.8 square kilometers per year. And this one is going to disappear in 2084. So our conclusion, once again, Scotland's forest will disappear first by about 2084, or about halfway through that year. So that's part one. Let's get into part two of the problem. This is the reforestation component. So for the reforestation plan, we can start by finding the increase in the number of years that we have. So remember, they have set some targets for us within the prompt. In the prompt, they say that we want to get it back, and it being Scotland's forest, we want to get it back to 175 square kilometers by the year 2092. But remember, we're starting with 50 square kilometers. So Scotland's forest is already at 50 right now. And that means that we have another 125 square kilometers left to go now that we're pivoting from deforestation to reforestation. So that's our target. We have to hit 125 square kilometers. And the question is, how long do we actually have to hit that mark? That's a lot to reforest. And from 2022 to 2092, that gives us about 70 years. So that means that we have to be reforesting at a rate of 125 square kilometers, and we have to tackle that in 70 years. So we divide those two. We have to reforest at a rate of 1.8 square kilometers per year. And we've rounded this value to the 10th decimal place. We read ahead a little bit, and they said round to the 10th place in part 3 of the prompt. So we've applied that same rounding mechanism or convention over here as well. Now, with that rate of 1.8 square kilometers per year, they also said, okay, well, what will it be in 20 years? How far along have we gotten by the year 2042? So remember, each year we're adding 1.8 square kilometers. So after 20 years, that means that we have added 36 square kilometers. So 36 square kilometers have been added. Remember, we started with 50. So in total at the year 2042, we are at 50 square kilometers plus that 36 square kilometers that's been added. So a total of 86 square kilometers, but we believe the prompt specifically asked for the change, right? How much exactly had been added in those 20 years? So that's part 2. Let's take a look at part 3 of this same problem. Here we have carbon absorption analysis. So they ask us a little bit about the CO2 impacts. Now, we have a little bit of information about the impact that deforestation initially had. And they said that the deforestation had released around 70 metric tons of CO2. And 1 metric ton they gave us is equivalent to about 1,000 kilograms. So in total, that deforestation released 70,000 kilograms into the atmosphere. Now, we have this reforestation process going on as well. And every 1 square kilometer that they plant will absorb about 10 kilograms per year of CO2. And they're going to be planting at a rate of 1.8 square kilometers per year. So the question is, okay, how much CO2 really gets absorbed in this process? And oftentimes we encourage students to step back from just jamming numbers into formulas without really thinking about the context first. Really what's happening here is every year they're planting more trees. So that means that every year the absorption is happening at a faster and faster pace. So we oftentimes encourage students to solve problems iteratively, try to identify patterns that are occurring. So for example, we can look at year one and know that, okay, we've planted 1.8 square kilometers in the first year, and that's going to absorb 10 kilograms times 1.8, or really 10 times 1.8. In other words, it'll absorb 18 kilograms in year one. Now that tree is planted, it continues to work. In year two, we're going to plant another tree, and that is going to do the same. It is going to absorb another 18 kilograms. So in total in year two, we're absorbing 18 plus 18 because they're, it's really 2 times the 18. And in year three, that'll go up to 54 kilograms. Now, that's perpetual. It's going forward. So really, what we're looking at here is summing up all of these numbers from year one all the way up to year 20. So we want to say in year one, 18 kilograms got absorbed. In year two, 36 kilograms got absorbed. In year three, 54 kilograms got absorbed, and so on. Now you could sit there adding these up manually. And frankly, it's very likely that most Algebra 1 classes in school are not teaching you this method, but there is a much faster way to add up these numbers. And here it is. We can use something called Gauss's formula, or the sum of an arithmetic series. And the formula that we're looking at is n over 2 times a sub 1 plus a sub n. In other words, take the number of items in this list. In this list from 18 to 360, well, that's going to cover 20 years. There's 20 items or 20 numbers in that list. So in total, our n value is 20. So we want to take n over 2, 20 over 2, or 10 pairs. So there's 10 pairs, and each pair is going to be a sum of 18 plus 360, or in other words, 378. Here's another way to think about it. This is how I teach a lot of our students in small group coaching. I will first ask them, okay, what's 18 plus 360? And a student will go, 378. What is 36 plus 342? Also 378. What is 54 plus 324? Also 378. So really, the way to think about this, we're identifying pairs. We're pairing the first number and the last number. We're pairing the second number and the second to last number. We're pairing the third number and the third to last number, and so on. And if we have 20 items in the list, well, we know we have 10 pairs, because each pair has 2. We have 10 pairs of 378. So in other words, it's 10 times 378, and that'll get us to 3,780 kilograms. And if we convert that to metric tons, well, using that ratio of 1 metric ton is equal to 1,000 kilograms, well, we know that that's approximately 3.8 metric tons. So that solves part 1 through 3. And here are our key takeaways and conclusion from the problem. These are our final answers, just to recap. The forests will match in size about 50 years later, so in about 2072. At the time of that match, their area is going to be about 10 square kilometers each. And Scotland's forest is the one that disappears first by around mid-2084. So even though Scotland started with more area, the deforestation was occurring at a much faster rate. Now, looking at part 2, we are reforesting at a rate of 1.8 square kilometers per year. And after 20 years, we would have a total of 36 square kilometers added, just by multiplying 1.8 times 20. And the answer for part 3, no, the newly planted forest will not fully remove all of Scotland's 70 metric tons of CO2 in 20 years. Not even close. So we always encourage students to be thinking about the broader context of these prompts. Think about other factors that might influence your solution. Remember, TJ really values the interdisciplinary. We never think about subjects like math or science in a vacuum. They are not necessarily distinct subjects, but rather they are overlapping. And there are oftentimes real-world variables that need to be factored into our analysis. So these are other variables that might influence your solution. And while they might not impact your mathematical answers, it can be worth discussing. So for example, climate variability can wildly affect the growth rate of trees. It can affect deforestation and reforestation progress. There could always be policy changes. We see that happening quite frequently, especially around environmental topics. There could be fluctuations in economic demand, which might speed up reforestation or deforestation. And there may also be advancements in technology that enable us to reforest more quickly or even deforest more quickly. Now, if you enjoyed the solution, this is a little bit more about us and our background. We're actually former TJ students who earned admission to TJ. We've been through the process, we've been there, and we really started EduAvenues in order to design a better, more flexible prep center that was better aligned with the TJ admissions exam. Now, we offer a wide variety of prep programs. We do also offer scholarships for students on free or reduced lunch. And many of our students are ultimately admitted into TJ, and we have several benefits in doing the work to prepare for the TJ admissions exam. If you'd like a little bit more information about that, please feel free to visit our website at tjtestprep.com, and we are wishing you the best of luck. Thanks for joining us today.